Okay, so back to the systems of equations, but with the calculator stuff. So let's start with number 6. So I'm going to just pull up my calculator and we're going to work some of this out. So the first thing I'm going to do, since now I need to make sure that both equations are set y equals. I have to have it in y equals then the equation because that's the only way I can type it in my calculator. So if you go, and number 6 is already set up like that. It says y equals x squared plus 4x plus 3 and y equals x plus 1. So it's already both equations set with y by itself. So it's ready for us to type in. Now in our calculator, what we're gonna do is I'll go ahead and start the main screen. What we're gonna do is hit y equals at the top left corner, and we're gonna input these equations. So we're gonna type in x. You can see where I'm typing on the screen. If you see like the button highlights red when I touch it. So x is that button next to alpha squared. Then plus 4x plus 4x and plus 3. Just hit enter just to make sure it's in there. And now I'm going to type in the second equation, which is just simply x plus 1. All right. So the question's asking, what is the solution set for the following system of equations? And I've got my systems of equations plugged in there. Now, remember, solution, as I discussed in the last video with numbers 1 through 4, is basically where the two functions are going to cross. Now, I'm going to have to readjust my window because this is not a very good look at it. I think I had this window set up previously for something different. So if your window is a bit off, then just go to your window button, which is kind of next to your y equals button, and just reset it so that its x min is -10, x max is +10, and then x scale is 1. And then same thing for your y min, y max, and your y scale. Yeah. All right, so -10, 10, 1, just like it is on my screen. All right, I'm going to go back to graph now that that's readjusted, and you can see it's reshaped my window so I can get a slightly better look at my system. So there's the first equation, there's a quadratic, and here's the second. So it's kind of tight. So you can kind of guess, it looks like, let me see if I can pull my tool up here. It looks like they're intersecting, I should use a different color, shouldn't I? Let's use like purple or something. Looks like they're intersecting. Oh, purple's even worse. Okay, because it's blue and red. I don't know. What's a color that stands out here? Yellow, maybe? Okay. They're intersecting here, which looks like about -2, -1, and here, which looks like it's about -1, 0. So if I were to guess, just based on the image I see, I would guess those 2 points. But here's a way to confirm. There's a couple ways to confirm. One is you can check your table by hitting second. Oops, I have to get out of that screen. By hitting second graph and looking for basically when the y1 and y2 are the exact same number. So you can see them, just go up a little further, but you can already see them in your table when y2 and y1 are the exact same number. So that's actually maybe green's better. Right here at -1, -1. So that's at -2, -1. And the other one is right below it. They're both there at 0. And that's -1, 0. So -1, 0. Those are the 2 points confirmed by my table. So again, when you're looking at the graph, you're looking for both y1 and y2 being the exact same thing. And you can see everywhere else on there, they're not the exact same thing. It's only there and there. -2, -1, and -1, 0. The other thing you can do, just to show you for future reference, is if you go back, if you hit second, oops, again, I gotta get out of that. Second trace, and you select the intersect option, you can have the calculator kind of guess. So you draw your cursor over to the point where you think they're crossing, like right about there. Hit enter again, because they're both basically at the same exact spot. and then hit enter one more time. So it guesses. So it's like 3 times hitting enter. And you can see it guesses the intersection is -1, 0. It says on the bottom of your screen. And you could test that again for the other point. Hit second, trace again, choose intersect, and just do it, move it over to where it looks like they're crossing on the other point. So they look like they're crossing right about there. I'll hit enter 1, 2, 3 times, and it says it guesses at -2, -1. So there's a couple things you can do, but there's your answer either way. For number 7, it's just a little bit more work. It's the same exact question, but notice the second equation is not set up in slope-intercept form, so that's the first thing you need to worry about. So we're going to put the first equation in the calculator in a second, but the second equation, 3y minus 6x equals 6. I need to set this up with y by itself. So I'm focused on y. I'm going to try to isolate y, try to get that by itself. Now to get that by itself, I'm going to have to move this x term over here, and I'm going to have to move the 3 over as well. But first, the x term. I'm subtracting 6x. So what I'm going to do to move it is add 6x to both sides. So by adding 6x to both sides, it's going to cancel out over here and leave me with just the 3y part equal to 6x plus 6. Now you cannot combine these in the 12x because they're not like terms. 6 is just a constant. 6x is an x term. They are not like terms. They do not go together, so they're just written separately as I've done that here. And then the last thing I need to do, this y, by the way, I don't know why I wrote x, 3y, is I needed to get rid of this 3. Because remember, I'm isolating this y. I'm trying to get this y by itself. So to get rid of this 3, I'm going to divide by 3. Oh, there's my y. Divide by 3 to get rid of the 3. That's going to divide everything by 3. So this is going to be y all by itself with that 3 gone. Changing colors is so hard sometimes. There you go. The y all by itself. Now 6 divided by 3 is going to be 2x. And then the other 6 divided by 3 is also going to be 2. So 2x plus 2. So there's my equations. I've got the original one, y equals x squared plus 3x minus 4. And I've got y equals 2x plus 2. So I'm going to put both of those in my calculator. So back to my y equals. I'm going to clear out what's already here. And I'm going to input my 2 functions. So first one is x squared plus 3x minus 4 plus 3x minus 4. Hit enter and then hit the next one, which was 2x plus 2. All right, we're going to graph and we're going to see where these two cross. So there's the first function, that's a quadratic. And here's the second one. All right, so just based on looking at the graph, it looks like it's about, let me write this down. It looks like it's about here, which is about -3, -4, just about. We'll check to see if that's right. And then the other one, which is here, looks about +2, 1, 2, 3, 4, 5, 6, +2, 6. But again, I'm a little skeptical on that because it is just looking at the graph, and my graph could be deceiving. But that's just my guess for now. Let's see the y equals. Let's see the table to see if that's confirmed or not. So second graph will take me to the table. And again, at the table, you're looking for where the y1 and y2 are the exact same. So they're the exact same. Let's try to highlight this. They're the exact same here, which is the point 2, 6. And they're also the exact same here, which is the point -3, -4. So we were right, but it's helpful to check the table to make sure. And also, if you want to go and use that second trace feature where you go over the intersection, you can see it'll work that way too. But I've already confirmed my answer, so I'm going to go ahead and move on. -3, -4, and 2, 6. All right. Now this is the fun one, okay? Number 9, I should probably do first, honestly. But We'll do number 8, and then number 9 will be even easier. So here's the thing with number 9, or number 8, I should say. We're going to use the calculator for this, and once we use the calculator, it's going to be really, really simple. But before I can use the calculator, I have to set the equations up, all 3 equations, with an x, y, z equal to my number. That's the format it needs to be in. Okay, most people would say it's ax plus by plus cz equal to d or something like that. But anyway, you need your x term first, your y term second, your z term third, and then equals whatever the plain constant number is. So that's not the case. You can see that is the case in number 9. Number 9, all 3 equations are written that way. So that's our goal for number 8, is to write the equation, all 3 equations like that. I think the last equation in number 8 is already like that. But the first equation is 4y plus 3x equals negative 51 minus 9z. So here's the thing. I already have the x and the y on the left side as I want them to be. I'm just going to rearrange them so that the x term comes before the y term. So I'm going to have 3x plus 4y. Now I know my z term is going to need to go here, and then negative 51 is going to need to stay there. So the only thing I have to move is my z term, right? My z term needs to be on the other side here. Now to move it to the other side, because it is minus 9z, I'd have to add the 9z to both sides. So when I move it over here, it's going to be plus 9z rather than minus 9z. So there's my equation. It's 3x plus 4y plus 9z equal to negative 51. So again, just to recap what I did, I noticed that the x and the y term were already on the left side, so I didn't move them. I just kept them over there, with the slight exception of just rearranging them, because I do want the x term to be first in the front, the y term to be second. And then I left a little bit of room for my z term, which eventually added its way over here. Negative 51 did not have to move because it is the constant. It is already on the right side. So that's my equation. 3, 4, 9, and negative 51 there. My second equation, negative 5z equals 24 plus y. So here's the thing. Same thing. I want it to be x, y, z, and then equals my number. So my number is 24. My 24 is going to stay there. There is no x term here. No matter how hard I look, there's no x term. There's never going to be an x term here. It's going to be 0x every single time. The negative 5z is already negative 5z. That's where it needs to be. The only thing I need to move is this y. The y needs to be over here. So to move it, I'll have to subtract y, which means when I put the y over here, I'll have minus y. So I have no x term, so 0x. I moved the y over, so it's negative y, and I kept the negative 5z as negative 5z, and I kept the 24 as 24, since those two things were already where they needed to be. So it's just a quick rearrangement of things. All right, and the last equation's already set up for us. The last equation, negative 11x minus 7y minus 12z equals 55, is all good. Now, the reason it has to be in order x, y, and z is because we're going to type it in the calculator that way. So let's go to the calculator, and I'll show you what I mean. So in your calculator, let's quit this. Second mode is to quit. And you're going to go to apps. So in apps, you're going to go down to the fourth option, Polysimals, whatever it's called. But POI-SMLT2, that app is the one we're going to use. So hit enter. It's got like a little welcome screen. Just hit enter again. And now we're going to choose the second option, Simultaneous Equation Solver. We're going to select that. Now it's going to ask us how many equations we have and how many unknowns or variables we have. We have 3 equations, right, that we just in our system, and there's 3 unknowns, meaning x, y, and z. So those are unknowns as like variables. How many variables you have? So we have 3 equations, 3 variables that we have to solve for. So make sure that you've selected 3 and 3, and then hit next. Now to hit next, you have to hit the graph button. You can't scroll down all the way. You can't go any further than that. So to hit next, you have to hit the graph button because it's the button right below on the screen where it says next. So choose that, and you're going to get either something like this or you might look slightly different, but it's set up the same way. So if yours looks like mine, then just go with what I'm saying. But if yours has the X, Y, and Z already kind of filled in for you, just make sure you plug the numbers in the same way I'm plugging mine in. So if you already have something there, I'm going to clear it just by hitting the zoom button in the middle. That's going to clear it. So now we have to put each of these. Well, let me sort of emphasize what this is doing. So this left side, whatever number I put here is going to be my X term, or the calculator is going to assume it's my X term. This number will assume it's my Y constant or my Y coefficient, then my Z coefficient, and this little bar represents my equal sign, and then the numbers over here would represent equals to whatever number. So that's why we had to have the equations in X, Y, Z equals our number, so that whenever I put it in my calculator knows what equation I'm representing. So the first equation that we had was, we had 3x. So I'm gonna hit 3, enter for the first entry, because that's going to tell the calculator 3x. I had 4y, so hit 4 for the y, and then I had a positive 9, so 9 for the z, and then equals negative 51. So that's telling the calculator 3x, 4y, 9z equals negative 51. So now I'm going to do this for the other equation. So the second equation had no x, so I'm going to leave it as 0. You can leave it as 0 because it was 0x. Then it was minus 1y, so negative 1 for the minus y. And then negative 5z, so negative 5 for the z, and then equal to 24. And the last equation, it's already perfect for us. We're going to hit negative 11 for the x, negative 7 for the y, and negative 12 for the z, equal to 55. So the calculator knows the problem that I've given it. All I need to do is solve. To solve, I'll just hit the graph button, because the graph button's right below solve, and it tells me my x, y, and my z. It says x1, x2, x3, but it is your x, y, and your z. X is 4, y is negative 9, and z is negative 3. So now you can do that same exact thing for number 9. So number 9, let's go ahead and do that. I'm going to clear out this one. So number 9, I had 2x, 1y, 4z equal to 29. I have 1x, 5y, negative 1z, and 7. And the negative 2, negative 4, and 1 equal to negative 3. All right. So as long as those are inputted correctly, it is worth going over and double checking to make sure that everything is put in as it should be. I'll let you guys solve it and hit enter, because I want you to do it on your own. I don't want you to just copy what I have on the screen here. So try it on your own, get the answer number 9, you'll be all set. So that's going to cover it for the systems. I'll see you guys when we cover what's next. Transformations? When we do transformations. Bye.